Welcome back to the deep dive. We are doing something a little bit different today.
Yeah, bit of a change of pace.
Usually we're taking this massive stack of sources, articles, research papers, sometimes leaked memos, and we're just unpacking a specific technology or maybe a historical event.
hmm We're in explanation mode, the what is this or how does it work mode.
Exactly. But today feels less like a classroom and more like, well, it feels like we're in the living room. It feels like we're staging an intervention.
It sounds a little dramatic when you put it that way, but yeah, it essentially is. It's a psychological intervention.
A psychological intervention for the tech savvy, for the curious, for all the people who listened to our deep dive last week on the nuclear option,
Right.
where we walked through exactly step by step how to turn a gaming PC into a sovereign AI server and then did absolutely nothing with that information.
And look, we have to be honest, that's a huge segment of the audience. We saw it immediately. The nuclear option was the technical manual. It was the how.
It was the blueprint.
The blueprint, exactly. It showed that if you have the hardware, you can build the brain. But we noticed this pattern in the feedback, in the community discussions, right after that deep dive dropped.
It's the read to action gap. It's a real thing.
It is. The hardware is sitting right there. The tutorial is bookmarked.
Mhm.
People are saving it to their read later apps, sending the link to themselves. But the execution,
The actual physical act of typing the commands.
into the happening.
The rigs are just gathering dust. Or, well, more accurately, they're just playing Steam games, which is fine.
Of course.
We love gaming, but that hardware is capable of running a synthetic intelligence, and instead, it's just rendering polygons for Call of Duty or Baldur's Gate.
It's underemployed hardware. That's the thing. So today isn't about code. We are not going to read you documentation. We aren't going to get into a debate about which version of Linux is the best.
Thank goodness.
Today is about the why. Why do otherwise incredibly smart, capable professionals hesitate to do something that is, when you break it down, actually quite simple? We are digging into the psychology of technical procrastination.
I love this because I feel so seen right now. I think we've all been there. You have the instructions, you have the gear, but you don't start. You stare at the screen, and then suddenly task in the world.
There's a specific phenomenon here, something I've seen in smart professionals for years. I call it the 14-day delay for a 20-minute task.
Oh, wow. That hits hard. That's painfully accurate.
It's universal. You'll see someone wait 2 full weeks just agonizing over a task, building it up in their head into this giant monster.
Losing sleep over it.
Absolutely. They'll put it on a to-do list, then they'll move it to the next day's list, then the next. And then when the deadline finally hits, or they just force themselves to sit down and do it,
It takes 20 minutes.
20 minutes. And half of that was getting coffee.
It's the mental monster under the bed. The anticipation of the task is just infinitely worse than the task itself.
It is. And the hook here, the thing we really need to debunk right at the top for this local AI project, is that the barrier is not technical complexity.
Right.
People think, oh, I'm not smart enough, or I don't know enough Python, or I'm not a hacker. That is not it.
So what is it then?
The barrier is the fear of breaking something. It's this deep-seated fear that you are going to ruin your expensive, perfectly running machine.
Okay.
But the reality is, and this is the key, we're talking about a feel of breaking something that has a 30-second fix.
A 30-second fix. That is the metric we're going to come back to again and again today. That changes the whole equation.
It changes everything.
Okay, so the vibe today is real talk. No sales pitch, no hype, just looking at why we freeze up when we see a command prompt.
Precisely. We need to dismantle these fears one by one. We need to take them out of the dark, put them on the table, and look at them under the bright lights.
All right, let's do it. Let's unpack this mental block. We've identified what the source material calls the 3 fake fears. This is the stuff that stops you before you even type the first letter.
Right. And fake fears is the perfect term because they feel incredibly real.
Yeah.
Physically.
Yeah.
You get that tightness in your chest, your palms might get a little sweaty.
Yeah, that's real.
But they're based on outdated information or just misconceptions about how modern software and these AI tools actually work. They are, for all intents and purposes, hallucinations.
Okay, let's hit the first one. This has to be the biggest one. Fear number 1. The daily driver fear.
This is the big one.
The anxiety of, what if I brick my computer?
This is the primary hurdle. Without a doubt. Most people, especially if you're just dipping your toes into this, you don't have a dedicated server rack in your basement.
No.
You don't have a spare laptop lying around just for testing. You have
Yeah.
your PC. It's your daily driver.
It's where you do your work. It's where you check your email. It's where you do your banking. It's where you play your games with your friends. It is the central hub of your entire digital life.
Exactly. And the idea of installing some weird, Python script or a local LLM
Yeah.
feels like, I don't know, pouring coffee directly onto the motherboard. It feels that destructive.
That is exactly how it feels. There's this irrational but very powerful belief that installing these kinds of tools is going to fundamentally corrupt the operating system. People are genuinely terrified they're going to delete System 32 by accident, or that the computer will be permanently slowed down like it catches a digital cold that can never, ever shake.
It's the fear of tainting the machine.
Yeah.
You look at your computer, and right now, it's running perfectly. It's fast, it's clean, the fans are quiet,
It's a pristine
a
environment.
pristine environment. And you think, if I introduce this developer tool, am I introducing chaos? Will I wake up tomorrow and find that my mouse driver doesn't work for some reason?
I have definitely felt that. You install one tiny thing and then your fans start spinning just a little louder than usual, and you immediately think, what have I done? Is it mining crypto for someone else now? Did I ruin it forever?
It's that immediate buyer's remorse, but for a free piece of software. It's the fear of the unknown. But we have to be crystal clear. Installing these tools in the way we recommend, which we will get to, is not surgery on the heart of the computer.
Okay.
It's not touching the kernel. It's not rewriting the BIOS. But that fear of breaking the device, of turning a $2,000 computer into a very expensive paperweight, that is what keeps the start button unclicked.
It feels like the stakes are incredibly high in our heads. Okay, so that's the fear of destruction. What about the fear of, well, time? That brings us to fear number 2, the rabbit hole fear.
Ah, yes. This is going to take all weekend fear.
Yes. The idea that if I start this on a Saturday morning, I'm going to look up and it will be Sunday night. I'll be surrounded by empty energy drink cans, crying into a cold pizza because I'm stuck on error message number 47.
It's the assumption that local AI is a 48-hour debugging marathon. And honestly, we have to forgive people for having this fear.
Why is that?
Because we have been conditioned by older tech experiences where that was absolutely true. Trying to set up a printer in 2005, that was a weekend.
Oh my gosh, don't trigger my PTSD. Downloading drivers from some shady-looking website, hoping they match your exact OS version and subversion.
And it never works the first time.
Right.
Or modding a video game 10 years ago. You'd spend 10 hours just editing config files by hand, resolving IP conflicts with your router just to play a game for 20 minutes.
Exactly. So the brain, based on that past trauma, it predicts, okay, this is complex AI stuff. It involves neural networks and inference engines and all these scary words. Therefore, it must be 10 times harder than setting up that horrible printer.
It's a logical leap, but it's a leap based on wrong information. You weigh the expectation of a ruined weekend, all that stress, frustration, inevitable failure, against the benefit of a cool chatbot.
And you say, nah, I'll just watch Netflix.
It's a completely rational economic decision based on bad data. We are fearing a phantom timeline.
A phantom timeline. I like that. It's a complete mismatch of expectation versus reality.
Totally.
And then there's the third fear. This is a subtle one, but I think it really gets the perfectionists. The no undo fear.
The registry ghost.
The registry ghost. That is such a great evocative image.
It's the belief that once you install these tools, Llama, LM Studio, Python, whatever, that even if you uninstall them, they will haunt a computer forever.
Yes.
That there's this digital residue left behind in the registry, these hidden folders that you can never fully scrub.
It's like glitter. You use glitter once for a project and you will be finding it in your house for the next 10 years. You can never get rid of all the glitter.
Exactly. People think Python is digital glitter. They think my pristine gaming rig, which runs Cyberpunk perfectly right now, will never be the same if I let this AI stuff in. It will be permanently soiled.
It's a fear of pollution, of digital clutter.
And it creates this sense of a before and an after. Before I installed Python, my computer was pure. After, it's messy. And since there's no clear undo button in the real world for these things,
People hesitate to commit. They don't want to cross that line.
so you have the fear of breaking it, the fear of losing your entire weekend, and the fear of leaving permanent stains on your hard drive.
These are the fake fears.
And people are paralyzed by them. It is a perfect storm of anxiety that leads to complete inaction.
So let's flip the script. Let's do the intervention. The source material counters these fake fears with the three realities. These are the safety nets that make those fears, well, basically obsolete.
Right. Let's bring the facts to the fight.
And the first one is my favorite metaphor of this entire deep dive, the hazmat suit.
This is critical. If you take nothing else away from this entire conversation, understand the concept of VEN.
Ven. It stands for virtual environment. But don't think of it as code. The name is intimidating.
No, do not think of it as code. That's the wrong frame.
Yeah.
Think of it as a hazmat suit. Or, even better, think of it as one of those sealed glass containment chambers in a high-security laboratory.
Okay, paint the picture for us. What does that mean in practice?
When you set up a local AI environment using Python, specifically following the method we laid out in the nuclear option, you aren't just tossing files into your hard drive willy-nilly.
Right.
You aren't mixing chemicals in the open air of your living room. You are first creating a specific sealed folder, a self-contained directory,
A sandbox.
a sandbox with very high walls. Everything, all the Python libraries, the dependencies, the weird scripts, the model weights, which are gigabytes in size, it all lives inside that one folder.
So if the AI explodes, if the code is bad, if it starts downloading weird stuff from the internet.
It explodes inside the hazmat suit. It melts down inside the sealed folder.
Yeah.
It never, ever touches your actual operating system.
So it can't get to my game saves.
It can't get to your game saves. It can't touch your tax documents. It has no access to your critical system files. It's in a cage.
That is such a relieving visualization. Because I think people imagine the installation spreading like digital vines throughout the entire system, wrapping themselves around the kernel.
Right, like a virus.
But it's really just a box. You put things in the box, and if the box gets messy, the mess stays in the box.
Precisely. You are the scientist observing the experiment through the thick glass. You are not injecting the experiment into your own bloodstream. This is not a system update. It is an isolated event.
Which is the perfect lead-in to reality number 2, the 20-minute setup. The source material calls this the 191 rule.
Yes, and this is so important for managing expectations. Because 20 minutes can sound like a lot if you think it's 20 minutes of intense, sweat-inducing hacking.
Right, 20 minutes of diffusing a bomb. So what is the 191 rule?
The 191 rule states that the entire process involves approximately 19 minutes of reading instructions or watching a tutorial and exactly 1 minute of actual typing.
That ratio is so important.
It is vital because the perception is that you'll be typing code like a hacker in a 90s movie. Yeah, green text scrolling down a black screen, furious typing for 3 hours straight.
I'm in.
Yeah, exactly. The reality is you are mostly just learning what to click. You are reading a blog post, you are pausing a YouTube video, you are absorbing information.
And the actual physical action, the part where you're doing something.
It's typing pip install, hitting the enter key. It's clicking a download button on a model inside an app. It is seconds of work. It is physically less demanding than writing a 2-paragraph email.
The source material makes a pretty bold claim here that I really liked. It says, getting a local brain, like Llama 3.18b, running on your machine is faster than watching a single episode of a sitcom.
And it's absolutely true. Think about how easily we sink 25 minutes into an episode of The Office or Parks and Rec. We don't even think about it. It's just a sliver of our evening. If you took that exact same block of time, sat down, focused, and followed the nuclear option guide, you would have a sovereign AI running on your machine before the credits roll.
It's not a marathon, it's a sprint. A very, very short sprint.
Exactly. The rabbit hole fear is based on a lie. It's not a weekend project. It's a coffee break project.
Okay, that's 2 fears down. Now for the third one, the big one for perfectionists. Reality number 3. This is the one that directly addresses the no undo fear, the registry ghost. This is the delete one folder solution.
This is the ultimate undo button. This is what I call the permission slip to fail.
I love that phrasing, permission slip to fail. Because we need that. We need permission to mess up without permanent consequences.
We do. And here's how it works. Let's imagine the worst case scenario. You do everything wrong. You follow the tutorial, but you make a typo somewhere.
Yeah.
Or you accidentally install the wrong version of Python.
Or the AI starts speaking gibberish, or it just doesn't work at all.
Or honestly, let's say you just decide you hate it. It's not for you. You don't want it on your pristine computer anymore.
Okay, so normally that's a nightmare. You have to go to Add Remove Programs, find 5 different things with confusing names, scrub the registry with some third-party tool, reboot 3 times.
Not here.
Yeah?
Here, because of that hazmat suit, because of that Venv we talked about, you just find that one folder, The one you created at the very beginning.
And you right-click it.
And you select delete.
That's it. There's no other step.
That's it. You drag it to the recycle bin, you empty the bin, and poof, it's gone, as if it never existed.
And the registry damage? The digital glitter?
None. Zero. It never touched the registry.
Your brick system.
Non-existent. You are back to zero. You are back to your before state in 30 seconds.
That is the 30-second fix we mentioned right at the start. The worst-case scenario isn't a dead computer, it's a deleted folder.
And when you internalize that, when you really understand that, the entire risk profile of this project changes completely. The cost of failure is zero. The time to recover is seconds. So why are we so afraid?
That is the psychological unlock. It takes this mountain of fear and turns it back into the molehill it always was.
Exactly.
But speaking of mountains, let's talk about the hardware mountain. Because I think another huge reason people hesitate is what I'd call gear envy.
Ah, yes. The hardware inadequacy complex. It's a real thing.
It's so real. You know, people look at OpenAI, they look at Google, they see these pictures of massive data centers, just acres and acres of server racks, blinking lights, billions of dollars of NVIDIA H100 chip.
Water-cooled, custom-built infrastructure.
And then they look at their gaming PC under their desk, the one they built 3 years ago, and they think, I can't do AI. I'm just a person with a desktop. I don't have a $40,000 server rack.
It's like looking at a Formula One car and thinking you can't drive to the grocery store because you only have a Honda Civic. The tasks are completely different.
Exactly. We need to debunk this assumption immediately. And the source material brings up a really simple, elegant standard for this. It's called the Minecraft standard.
The Minecraft standard. This is a reality check that everyone who owns a PC needs to hear.
So what is the rule? What's the standard?
It's very, very simple. If your computer could run Minecraft with a few mods, or, to be a bit more demanding, if it could run a game like Cyberpunk 2077 back in the year 2018.
Wait, 2018? That's eons ago. In tech years, that's what, 8 years ago from now?
It is, but that's the entire point. You do not need cutting-edge, enterprise-level gear to run these powerful local models anymore.
So why not? What changed?
The optimization's gotten incredibly good. The models themselves have been compressed. There's a process we call quantization, so they can fit onto consumer hardware without losing too much of their reasoning ability.
So we can talk specific specs. What is the actual baseline we're talking about here?
For a really good experience with a model like Llama 3.18b, we're looking at a GPU, like the NVIDIA GTX 1070.
A 1070. I literally have one of those sitting in a box in my closet. I think I tried to sell it on eBay for $50 a year ago and nobody bought it.
Exactly. That $50 card that's collecting dust, a GTX 1070 paired with 16 gigabytes of system RAM. That is sufficient.
And Llama 3.18b, that's not a toy, right? That's a capable model.
Not at all. It's a very capable model. It can reason, it can write code, it can analyze data, it can summarize documents. It's a serious tool.
So the barrier to entry isn't, do I have $40,000 for a new server? It's, do I have an old gaming rig from the last decade sitting around?
It's about resourcefulness, not budget.
Yeah.
And honestly, there's a bit of a flex here that I've seen in the community that I really, really appreciate.
What's the flex?
The flex is using that dust-collecting, older hardware to learn about data sovereignty and build your own AI. It is actually, in a way, more impressive than just going out and buying the newest Chinese gear.
It's the sleeper build, like in car culture.
It's a hot rod built from scrap parts in a garage that ends up beating the brand new factory car. There's a real sense of pride in that. You are squeezing incredible value out of hardware you already own to build something genuinely futuristic.
So if you are listening to this right now and you're looking over at your slightly dusty tower, maybe the RGB lights are flickering a little bit and you're thinking it's obsolete. It's not.
It's not obsolete. It's a dormant server. It's a dormant brain. You just need to wake it up.
Okay, so we've cleared the fear. We've validated the hardware. The excuses are dwindling. Now let's talk about the tools. Because even if you are brave enough to start, the landscape itself can be confusing. There are just so many names thrown around.
Oh yeah, it is a crowded space. It's alphabet soup. You hear about Llama, Gen AI, GPT-4All, Automatic 1111 for images.
And that creates the paradox of choice. You freeze because you don't know which one is the best one, and you don't want to waste your time learning the wrong one.
Right. You spend 3 hours researching which tool to use, and then you run out of energy to actually use any of them.
Exactly. So can we do a quick lightning round on the main alternatives before we get to the core recommendation, just so people have a mental map of the landscape?
Sure, absolutely. Let's start with Llama. Llama is fantastic. It is probably the darling of the developer world right now. It's incredibly lightweight, it's fast, it's efficient,
There's
but
us.
it's command line focused. It lives in that scary black box with white text. For a beginner, for someone who isn't a professional developer, it can be intimidating.
Okay, so great for devs, maybe not the first step for a learner. What about the others?
Then you have tools like Jan.ai. Very beautiful, very clean UI. It's extremely privacy focused, which is a huge plus. And then there's GPT-4 All, which is fully open source and very versatile. It runs on almost anything. They're all good tools. I want to be clear about that.
But for the learner, for the specific profile of the person we're talking to today, what is the starting recommendation?
For the listener of this deep dive, the starting point, the on-ramp, should be LM Studio, hands down.
Why LM Studio specifically? What makes it the best for beginners?
Because its entire design philosophy is about lowering the barrier to entry as aggressively as possible. It is designed for people who are used to using apps, not terminals.
It has a visual settings menu, a GUI.
Exactly. There's no scary command line flags to type in just to change the creativity of the model. You want to change the temperature. There is a
Right.
literal slider you can drag with your mouse. You want to change how much memory it uses. There is a drop-down menu.
And the model downloading process. I think this is the absolute killer feature for a beginner.
It is. In some other tools, you have to go to a website like Hugging Face. You have to find the exact model file, copy a long link, go back to your terminal, run a curl command. It's friction. It's a bunch of steps where you can make a mistake.
So how does LM Studio do it?
In LM Studio, there is a search bar on the left-hand side of the app. Looks in the App Store.
Just like an app store.
You type Llama 3. It shows you all the available options with community notes on which ones are best. You see one you like. You click a download button. A progress bar appears. That's it.
That is huge. That removes so much of the intimidation. Being able to just search and click download instead of hunting for magnet links or API endpoints.
It provides the best, most intuitive UI for beginners. It gives you constant visual feedback. You see the chat window, you see the model loading bar. It feels like a piece of software you already know how to use.
So we're recommending LM Studio as the on-ramp, as the starting point. But I want to dig a little deeper into how all these different tools actually fit together. The source material uses a really helpful body metaphor for this, the anatomy of the stack.
Right. The stack is one of those jargon words, and jargon is scary. So let's break it down with that body analogy to explain how all the pieces fit together.
Okay, let's build the creature. Let's start at the bottom. Python.
Python is the engine. It's the underlying power source that makes everything else run. You might not see the engine while you're driving your car, hopefully you don't, but without it, you are not going anywhere. It provides all the core logic.
It's the foundation. Then we have LM Studio, which we just spent time on.
LM Studio is the body. It's the chassis of the car. It's the dashboard, the steering wheel, the seats. It's the part of the system that you actually click on and interact with. It gives everything a physical form on your screen.
Okay, engine, body. Then we have the model itself. Let's use Llama 3.18b as our example.
That is the brain. That is the actual reasoning capability. It's the neural network that has read a huge chunk of the internet and learned how to think, how to connect ideas. It's small enough to fit on your PC, but it's smart enough to reason through complex problems.
And now we get to the really cool next level part. The source mentions a tool called FastMCP.
FastMCP represents the hands.
The hands. Okay, why does the creature need hands?
Because a brain in a jar can think all day long, but it can't do anything in the real world. It's locked in the box. FastMCP is a tool that allows the AI to safely touch the internet. It allows it to look up a current stock price, or check tomorrow's weather, or query a live database. It gives it agency.
And finally, there's the protocol itself, MCP, the Model Context Protocol.
MCP is the bridge, or you can think of it as the permission slip. It is the digital handshake that connects the brain to the hands. Nothing happens without this protocol saying, yes, it is okay for this specific model to access this specific tool. It's the safety layer.
I love that breakdown. Engine, body, brain, hands, and the bridge. It makes it feel like you are assembling a creature, not just installing a bunch of disconnected software.
You are building a synthetic agent. And when you understand the anatomy of it, it's so much less scary.
Yeah.
You realize that you can swap out the brain, just load a new model, or add new hands by adding new tools, all without breaking the whole system. It's modular.
Now, I want to pivot from the technical to a really interesting philosophical point that came up in the research. We talk a lot about shadow IT in the corporate world, and usually people say it with a shudder.
Oh, yeah. CIOs and heads of security, they wake up in a cold sweat thinking about shadow IT.
For those who might not know the term, shadow IT is basically when employees use software or devices that haven't been officially approved by the company's IT department.
Right, like using your personal Dropbox account for work files, or signing up for some new SaaS tool with your company email without getting it vetted. In a corporate setting, it's seen as a major security risk, a vulnerability.
But we need to contrast that corporate approach to AI with what you, the listener, can do at home. The source material brings up a fantastic case study from the bank BNY Mellon.
Yes, BNY Mellon recently deployed 20,000 AI agents to its workforce, which, to be fair, is an impressive feat for a huge regulated institution like a bank. It's a massive deployment.
But there's a big but coming.
But those corporate AI agents are what I call company cars.
Company cars. Explain that.
Think about a car you get from your company. It probably has a speed limiter on it. It definitely has a GPS tracker. Its usage is governed by a long handbook written by the risk committee, the legal department, the compliance officers, and the PR team.
They aren't going to let you take it to a racetrack and drive 150 miles per hour.
No. They might not even let you turn left at a certain intersection if turning left is considered a reputational risk that day. They are designed to be safe, they are constantly monitored, and ultimately, they are neutered. They have limits baked in.
Now contrast that with the listener's setup. The local agent, the creature we just described building.
Your local agent is a hot rod that you built in your garage.
A hot rod.
It has no speed limits. It has no compliance officers looking over your shoulder.
Yeah.
There is no legal team telling you what you can and can't ask it. It answers only to you. You set the rules.
That is a really powerful reframing of the situation.
It is. You, sitting in your home office, have more operational freedom than a multi-billion-dollar bank has in its own headquarters. You can experiment with models that have no safety filters. You can build tools that connect to weird, obscure APIs. You can push the limits. You can break things.
So we need to reframe the term shadow IT. When you are doing this at home for yourself, it isn't a security risk.
It is distributed R&D. You aren't a rogue employee creating a vulnerability. You are an innovator. You are the research and development department of your own life and your own career.
I love that. Distributed R&D. It turns that old hacker in the basement trope into something proactive, positive, and legitimate.
And honestly, that is where the real breakthroughs almost always happen. Not in the highly managed committee meetings, but in the garages and home offices where people are just curious enough to see what happens if they connect A to B.
So we've tackled the fear, we've validated the hardware, we've picked the tools, and we've even established the philosophy behind it. But I want to come back one last time to the learner who is still on the fence, still hesitating. Because sometimes all the logical, technical arguments in the world aren't enough. Sometimes you need a cultural translation to really make it click.
You need to speak their language.
And for a huge number of our listeners, that language is gaming.
Yes. This is a great point. The source material provides some fantastic gaming analogies to help contextualize the difficulty level here. Because a phrase like installing a local LLM sounds really hard. But is it actually hard compared to the things that gamers do for fun every single day?
Let's take a big one. World of Warcraft.
Right. If you have ever wiped on a raid boss 50 times in a row, if you have coordinated with 24 other people over Discord, managed your ability cooldowns, optimized your gear score down to the last stat point, and read forums for hours to figure out the exact drop rate of some rare item,
You can absolutely handle a virtual environment.
setting up a VM is significantly easier than a mythic raid. It involves less coordination, takes less time, and most importantly, nobody is going to yell at you in voice chat if you mess up.
The stakes are infinitely lower. Okay, but what about the casual gamers? The source had a great and very funny one for them too.
Hello Kitty Island Adventure. And look, it's a bit of a self-deprecating joke. It's got a little South Park energy to it. But the point is completely valid, it says. If you have spent 40 hours in Hello Kitty Island Adventure, collecting virtual items and decorating your digital island, you can handle typing pip install one time.
It just puts the effort into a stunning perspective. We spend hundreds of hours mastering incredibly complex systems inside of games. The skill tree in a modern RPG is often more complicated than the entire installation process for Llama 3.
Exactly. We already have the cognitive capacity. We have the patience. We just mentally categorize gaming as fun and easy and using a terminal as work and hard. We need to realize they draw on the exact same skill set. It's just problem solving. It's following instructions. It's a little bit of trial and error.
So let's bring this all together. Let's land the plane. The final realization we want the listener to have right now, sitting here with us.
The realization is this. The technical barrier you're imagining is a 30-second fix. Deleting a single folder. That is the absolute worst thing that can possibly happen. The real work, the only work, really, is getting over the psychological barrier.
It's just overcoming that initial inertia, that first step.
And look at the cost. Let's talk dollars and cents. Data sovereignty costs $0 financially. You already own the hardware. You already have the GPU. The electricity is already being paid for. The software is open source and completely free.
So the only cost.
The only cost is the courage to click start.
That is powerful. It's not a financial investment. It's an emotional one, a very small one.
And the return on that tiny investment is huge. You get privacy. You get a tool that learns with you and only for you. You get to be part of the distributed R&D network that is building the future, rather than just being a consumer of whatever corporate AI hands down.
I think that frames it perfectly. We started this depth dive wanting to perform an intervention. And I honestly feel like we've stripped away all the excuses. The hardware is fine, the software is safe, the time commitment is minimal. The only thing left is to do it.
To take action.
Now, if you were listening to this and you were thinking, okay, I'm ready, I have the courage, but I genuinely don't know which buttons to click, then you need to go back.
Yes. This conversation was the why. You still need the how.
Go back to last week's deep dive, the one we called the nuclear option. Or even better, go right to the source of all of this, AI, frankly.
Right. If this discussion helped you get unstuck, if it was the little push you needed to get over that mental hump, then subscribe to AI Frankly.
You can find it on Substack at afrankly.substack.com. That's where you get the newsletter and the full detailed articles. You can find the podcast version on Apple and Spotify, wherever you're listening right now. And there are video tutorials on YouTube if you're the kind of person who needs to see exactly what to click.
And the promise is simple. It's weekly updates, it's new experiments, it's honest reviews of what works and what doesn't. There's no hype, just receipts.
Just receipts.
Yeah.
I like that. We need a lot more of that in the AI space.
We really do.
All right, I think our work here is done. The intervention is complete. The rest is up to you.
Indeed, it is.
So, until next time, see you in the terminal.
Delete the fear, trust the folder, build the server.